My name is B.Gamor, and I'm working on the second problem, which is the cylindrical propane tank. Um, I'm solving for the part A, which is to determine the minimum wall thickness of the cylindrical part of the tank. Is using the formula of a stress, which is equal to the force, which is P times R over T, which is the thickness. And we have two formulas. It all depends on what part of the problem you're solving. I mean, like the cylindrical part of it is a one whole unit. So we're just using the stress, which is equal to PR over T. The P is given as the pressure, which is 120 psi, and the diameter of the cylinder is 40 inches. So half of that, which is the radius, which will be 20, and then our stress is being given as 12 kips per inches square, which is 12,000 pounds per inches square. So just manipulate the formula, which is stress, which is equal to PR over T, which implies that the T, the algebra part of it, the T is equal to PR over the stress. So that will be 120 pounds per inches square times the 20 inches, all divided by the 12,000 pounds per inches square. So my minimum thickness of the wall of the cylinder gave me 0.2 inches. The same goes for the B part of the problem, which I requested for to determine the minimum wall thickness of the spherical end caps. The end caps are 2 units. So we're looking for the minimum thickness of the end caps. So we're now going to use the same formula, but this time it has to be divided by 2. So our stress will be equal to PR over 2T, which is the 2 sides of the thickness of the wall. So by manipulating the same equation, we've already been given the stress to be 12 ksi, and we have the pressure to be 120 psi, and then R is the same, which is 20 inches. So we manipulated the same equation again, and so my equation becomes 120. My T will be equal to 120 times 20 inches divided by the 2 times 12,000 pounds per inches square. So the minimum thickness of the cap will be 0.1 inches. So that goes for the B part of the problem. And then the C part of the problem, which is what is the minimum thickness of the wall. The same goes for the wall too. We use the same formula that we use from the B part of the problem, which is the stress, which is the stress equal the P times R over 2 times the T. Since we're looking for T, we just manipulate it's just algebra. You manipulate the unit and send the T to the other side, and your equation becomes T equals your PR over 2 times your stress. So that will be in this case our pressure is the same, stays the same, 120, but the wall stress, the stress for the wall was given as 8 ksi. That is 8,000 pounds per inches square. So our equation becomes T equal 120 times the 20, which is the R, you deduce from the diameter given to you in the problem, divided by your 2 times the 8,000 pounds per inches squared. And with that, the math gave me 0.15 inches as the minimum thickness of the wall. That ends my solution to problem number 2. Thank you.